Hi guys, so this is the video for help on polar coordinates on the Ferris wheel, page 59. And let's begin by reading number 1 together. So suppose a Ferris wheel has a radius of 40 feet. I have a picture of a Ferris wheel right here, so I'm just going to draw that 40 feet. And a period of 20 seconds. So the time it takes to go around once is 20 seconds. That's the period. And the rider passes the 3 o'clock position at t equals 0. Find both the rectangular coordinates and the standard polar coordinates of the rider when t is equal to 3, using the center of the Ferris wheel as the origin. So here's what we have to do first. We have to determine this angle right there. So in other words, the angle when t is equal to 3 seconds or after 3 seconds. And we can do that using the angular speed. So this Ferris wheel, it takes 20 seconds to make one full rotation. So what we can calculate is the angular speed. In other words, how fast is it going around? Looks like if it takes 20 seconds to go all the way around, it's moving pretty quickly. So if you can remember, think back to like outcome 1, outcome 2, the way we calculated angular speed is we took 360 and divided by the period, which in this case is 20 seconds. And that's equal to 18 degrees per second. Okay, so we know that it's 18 degrees per second, and we know that we're looking for the position after 3 seconds. So how are we going to calculate this angle? Well, we're simply going to take the angular speed, 18, and multiply it by the time. So this angle would be 18 times 3, which I believe is 54 degrees. And you can double check me on that. So perfect. We know the angle, we know the radius, and now, do we know the polar coordinates of this point up here? Well, polar coordinates require two things. They require the radius and they require the angle theta, r comma theta. Well, do we know both of those? Yes, we do. We know the radius is, well, it's 40. And this angle theta from the 3 o'clock position, we just calculated, 54 degrees. Yep. So that was easy. So now what you guys can do is you can convert this polar point, 40, 54 degrees, into a rectangular coordinate. And you all should know how to do that. Okay? I'll give you a hint. What you're going to do is you're going to use this right triangle to calculate y, the height of the triangle, and x, the base of the triangle. And you have some trigonometric tools, namely sine and cosine, to do that. So that's number 1. On number 2, you're finding a value of t different from 3 seconds for which the rider would be in the same position as in question 1. So let's think about this. The Ferris wheel is going to go around, and it's going to return to this exact same spot how many seconds later? Well, it's going to return to that same spot 1 period later, or 20 seconds later. So could we figure out how much more degrees that is? Well, it's going to return to that exact same spot 360 degrees later. So what we can do is we can add 360 to this 54, and we would get our new polar coordinate, and we would get our new time. Okay, so add 20 seconds later to get the new time, add 360 degrees later to get the new polar coordinate, or the new theta, okay, which would give you the polar coordinate. I know that may be a little confusing, so email me if you have questions on this assignment. Thanks.